Unit 8, Part 10. Let's do K from pages 165 to 6 of Klenk. This is a really wonderful problem. I recommend you try it. Okay, we could take stock of our premises and just take a look at the form of the premises. Let's see if there's any automatic things we might do straight away. You'll notice that 3 is a conjunction, so we might go ahead and automatically simplify, right? Whenever you see a conjunction, you can simplify. Let's write it down. E and negation of F or D, 3 simp, 3 simp. Now, if you compare what we've done so far with Klenk's answer, you'll see we've already done something she doesn't do. She never does simplify to E. It'll turn out because it's not necessary to do so. But let's continue on. Look at that. Let's now, if you look at 5, right, take note of the form of this. A happy face has appeared, right? This is a negated disjunction. That's the happy face emoticon. Negated disjunction is the happy face emoticon. Why? Because this puts me in mind of De Morgan's, in the special form of De Morgan's, where I get a conjunction as a result, right? So not F and not D, 5 De Morgan's, right? Not F, not D, 6 simp, 6, right? It's a happy face because negated disjunctions are happy faces because it allows 3 quick moves which get us the conjuncts, the resultant conjuncts all by themselves. Okay, so we have that. That being done, okay, we did a whole bunch of stuff on 3, got us E and not F and D all by itself, right? So we're probably done with the premise 3. Now we'll be working with some of these. Not this one, it turns out. But, look at 1 and 2. 1 and 2 are conditionals, okay? Nothing to do immediately, but we're thinking we're probably going to do modus ponens and modus tollens. But now's a good time to look at the conclusion, and you might have started by doing so. Look at the conclusion and ask yourself, where does this conclusion, plus or minus a negation, appear amongst the premises? Here we arrive at a similar thought to the way we started the last problem that we just did. A only appears in the first premise, right? And thus only as a very buried subformula, right? So A plus or minus a negation, plus a negation, appears as part of the antecedent of this conditional. So notice what notice what we are noticing and what we are focusing on here, right? I'm looking at A appears as part of this formula, right? The major operator of this formula is a conditional. It is a conditional, and it's part of, right, an embedded part of the antecedent, okay? And now, just like in the last problem, so we think, right, we're going to get this part by itself by modus tollens. It will give us the negation of that part, and here, thinking forward again, we'll arrive at a very similar thought to one we got in the last problem. That is, if we can do that, if we can do the modus tollens and get the negation of the antecedent, that gives us another happy face, right? A negation of this disjunction, which by De Morgan's will give us a conjunction, one of the conjuncts of which is not A, and not A is equivalent to A by double negation. Okay, so we're home free once we perform the modus tollens on 1. So our problem resolves to getting the negation of the consequent of 1, right? So I need this, not brackets, not C or D, right? That is my task, right? Be clear when you're working through these and working backwards, right? I've made a lot of progress in my proof. I haven't written anything else down beyond the top-down reasoning I did, but I've made a lot of progress in realizing that this specific formula is what I need. When I get it, I'm home free, right? Once I get that, I do the modus tollens with that and 1, and then it's just De Morgan's, simp, double negation, and I'm done. All right, so how do I get this, right? Now all my attention goes to this. This is a negated disjunction, right? It's put over here, it's not on the proof because I've determined that I need this, okay? But how do I get it? Well, I would notice that this formula by De Morgan's is equivalent to, right? First of all, let me check to see if this formula, maybe minus a negation, right? Does this or something very close to this formula occur as a block anywhere else? No, it doesn't, right? There's no not C or D part anywhere else except for exactly 1, which is the one we were using to realize that this is what we need, right? So it doesn't appear anywhere else. It's not going to break off. It's not like this is a conjunct of a conjunction, in which case we can just simplify to get this. No. So we're going to have to work towards getting this. Okay, so what is this equivalent to? It's equivalent to, by De Morgan's, not C and not D. So what's the thought I have? The thought I have is, if I can get this now, I'm home free, because from this I can infer this by De Morgan's, and now my problem resolves to, how do I get this, right? What rule has this as a conclusion, right? By the way, I could have said that for exactly this. What rule has this as a conclusion? De Morgan's has this as a conclusion. I don't think anything else has a negated disjunction as a conclusion, but De Morgan's does, so I can get this from that by De Morgan's. Oh, now this is a form which looks more promising in that this form is a conjunction. The rule of conj has conjunctions as the form of its conclusion. So now I know if I can get not C and not D separately, I'm home, right? Look at this. Not D I've already got. Tick, right? I'm already halfway home. So all that remains is for me to get not C. Okay? Once I get that, I'm home free. This is rigorous determination of what it is you need, right? Now, if you have those thoughts in the right order, you get to where, okay? So now I need not C. So where does this plus or minus a negation appear? Looking at the other premises. And you might think, look, these were the first 3 premises. 1 to 3, prem. We sort of exhausted all that information by doing these moves. This we just dealt with. We just thought our way through with this. So let's look at 2 now. And in fact, 2 is very pertinent here because this formula, minus a negation, appears as the antecedent of that conditional, right? Which means I can get exactly what I need, not C, by modus tollens, if I can get what? Not E and F, right? So this is working backwards. At each step, it's an arrow like this, right? I need this. How do I get it? From this, by the rule of De Morgan's, right? I need this. How do I get this? By conjunction, if I can get this part I've already got. Okay, how do I get this, question mark? From this by modus tollens, right? From this formula by, I'm going to get it by modus tollens if I need, and so what formula do I need to use that rule? This one, okay? So now my problem resolves to, how on earth do I get that? Okay, if you've thought your way through to this point, you're doing well, but here is where your knowledge of the proof bits comes in again, okay? And notice there is a distraction here, okay? I need not E and F, right? What have I got? I've got E. If you're not confident in this stuff, you will crack your head open for ages trying to figure out how you're going to get from E to not E and F. There is no such path, which is why Klenk does not even make this move, right? E is a distraction. It's a red herring. It has nothing to do with the proof. Remember, not every formula needs to be used. Not every premise needs to be used. It's not quite a premise, but it's the one conjunct of a premise. But you don't actually make any use of E, even though you might think you do, right? Because what is this equivalent to? Okay, not E and F. That's equivalent to. Okay, not E and F by De Morgan's is equivalent to not E and F, right? I see this. What rules have formulas of this form as a conclusion? De Morgan does, right? Here, negated conjunction is equivalent to a disjunction of negations, right? Not E or not F. What do you notice about this? That it's the form of a disjunction, right? That means potentially I could get this by what? By addition, right? If I have either one of these, not E or not F, then I can add the other one, right? If I have given one, and see how it's functionally true. If I have either one of these, that means if I'm given one of these, or I've derived one of these, that means I'm given that as true, in which case it would also be true that either that or whatever else I want is true. That's rule of addition, okay? And you have not F. So it turns out you actually get this by adding, again I'm adding to the left, second form of add, not E or not F, not E, so I'm, sorry, not F, I'm adding to 7, add, right? Not E or not F. Now I just complete the proof. That becomes not E and F by 9 De Morgan, right? This is now, I'm just putting in place all my working backwards thought. That, I wanted that because it's equivalent to that. I want that so I can do modus tollens on 2. 2 and 10 gives me 11. Not C. I wanted not C. So I can conjoin it with not D, right? 12, not C and not D. 8, 11 conj. Right? 8 and 11 conj. That's equivalent to this, not brackets, not C or D by 12 De Morgan. Okay, I'm going to stop it, but this, right? Now modus tollens on 1, right? And then De Morgan on 1, double negation, and you can complete it from here. Okay.